Hello, ev- hello everyone. Today we are going to discuss about ortho and para hydrogen. Okay. So first of in the previous session, we have discussed the Hitler and the London treatment. Today we are going to discuss about ortho and para hydrogen. So you know that the hydrogen hydrogen molecule have it's a hydrogen molecule is a diatomic molecule. Okay. So each hydrogen atom consists of a one electron and one nucleus. In the nucleus, the proton is present. Okay. So electrons are revolve around the nucleus. Okay. So these electrons are spinning about its own axis and revolve around the nucleus. So each electron has a spin same as the same same wise proton has also a spin. So based on the spin of the proton can be classified into the two types. One is ortho and one is para. Only the based on the spin of the proton only, not on the based on the electron. Okay. So what I'm so hydrogen molecule consists of a two atoms. So each atom consists of a one electron and one proton. Okay, each proton have a spin. Each electron has also a spin. So based on the spin of the proton only, it is classified into the two types of hydrogen atoms. One is orthohydrogen, one is parahydrogen. Okay, so uh, if the if the protons are spinning in the clockwise direction, means all the spins are in the same direction, spinning in the same direction, in the same direction, then we call that hydrogen as an orthohydrogen. Understood? So if you see this in the proton, all the in orthohydrogen, all the protons uh, are spinning in clockwise direction, means spinning in same direction. So we call it as orthohydrogen. When the when the when the spins of the proton are orienting in the opposite direction, then we call it as a parahydrogen. Okay. When the parahydrogen, the spin of the proton are in the opposite direction. They are orienting in the opposite direction. Understood? Okay. This is the difference between the hydrogen and the parahydrogen. So based on the proton spin, it is based on the spin of the proton is classified into the two types of hydrogens. Okay, hydrogens are classified into two types of hydrogens. So one is parahydrogen, another one is orthohydrogen. Okay, so let me see the what is the variation between the ortho and para with respect to the temperature. So with respect to the temperature, at 0 Kelvin, ortho is not stable. Its para is completely stable. Okay, at 0 Kelvin, the para is completely stable. So at, liquefaction temperature, the both are stable at 50%. So ortho is stable at 50%. The para is stable at 50% or 50%, 50% critical. Okay. At room temperature or high temperatures, so it is 75% stable. The one para is 25% stable. Okay. So I hope you understand the. So we are now I'm demonstrating the what is the difference between the ortho and para. I'm showing the variation between ortho and para with respect to the temperature. At 0 Kelvin, the para is completely stable. At liquefaction, uh, ortho is 50% stable and the para is 50% stable. At room temperature, it is 3% stable means 70% stable. Okay. Basically, normal hydrogen, it consists of a both ortho and para hydrogens. Okay. So let me see how these para how do how we convert this para hydrogen into the ortho hydrogen. So when temperature increases, the para hydrogen is converted into the ortho hydrogen. Understood? So when temperature increases, the para is uh, converted into ortho hydrogen. So first take the para hydrogen. So heat it up to heat it at 800 degrees centigrade. Then the para hydrogen is converted into ortho hydrogen. Means all the spin all the spin which are oriented in the opposite direction can be converted into the same direction. All the spins are rotated in the same direction. So, okay. Or if we subject the catalyst like iron or platinum, the so by that para hydrogen atom is converted into the hydrogen atom. Or else um, use this the the oxygen, or if you subject oxygen or NO or NO2 to the para hydrogen, so then it is para hydrogen is converted into other hydrogen molecules. So what does it mean? So all in para hydrogen, all the in proton in a proton, all means one proton will orient in one direction, another proton is orient in another direction. So the resultant spin will be in the para hydrogen will be zero. The resultant spin in the hydro or the hydrogen is doubled. Okay, something will be there. Okay, so both both are having the same chemical properties, but are they varied in physical properties. If we see the melting point, the melting point of the para is 13.83 Kelvin and other is 13.95 Kelvin. Whereas in the boiling point, the boiling point is 20.26 Kelvin and the other is 20.39 Kelvin. As I said that in para hydrogen, the net spin will be equal to zero because one proton is oriented in one direction, means clockwise, another one is oriented in the anti-clockwise. So the resultant spin of the para hydrogen is zero. If we see in the uh, if you see in the other hydrogen, the resultant spin will be double because all the spin of the protons are oriented in the same directions. Okay, it, so it is a so therefore the in other hydrogen the net spin will be zero. Okay, I hope you understand this today's lecture. So hope I will see you in coming section. So in coming section I will explain the time independent perturbation and approximation methods. Okay, thank you.